content. Welcome to Why Hyper-V for VDI. My name's Gareth James. I'm a senior consultant with Microsoft Consulting Services based in Canberra. I'll let my partner in crime introduce himself.
Yep, that I am. My name's Tony Sanchez. I'm with Citrix Systems. I work on the Worldwide Alliances architecture team, specifically focusing on Zen desktop integration with Hyper-V and System Center.
So just a little bit of information about where I'm coming from in terms of this session is, because I'm in consulting, I spend most of my time at customer sites actually implementing the technology and doing engagements and deployments. So I'm not a marketing person, as will become immediately and apparently obvious from the quality of my slide deck. And I'm not a sales guy, so you're going to get pretty much a pretty factual how things really are with the technology and how it really works. And being in consulting and architecture, you really have to be realistic about what technology can and can't do, where its limitations are, and where it's used most appropriately. Okay, so with that, I'll kick things off. Now, this Why Hyper-V for VDI session is actually really a sort of a part one, part two, with the part two session being at bright and early at 8:15 tomorrow morning. So if you want the part two session, I'd recommend maybe not hitting it too hard at the attendee party tonight. This session is the why, and the next session that we have at 8:15, which is the scaling past 1,000 virtual desktops on Zen Desktop using Hyper-V, is really the how. So this session I'll go through some of the theory as to why Hyper-V is such a great hypervisor for VDI workloads. But it's going to be largely theoretical with a couple of little demos whacked in. And then in the next session, which is the 8:15 tomorrow morning session, we'll be going through a lot of the how. So the scalability testing that Citrix and Microsoft did along with HP, what that hardware architecture looked like, how we built it, what the Hyper-V and the Zen Desktop architecture was, what were the scalability results that we got, where the bottlenecks were, and that type of information. So the session objectives and takeaways. Firstly, I just want to spend a little bit of time on just what is VDI anyway, and a take on where we think the VDI is in terms of things like ROA and TCO. What makes a good VDI platform? What do you look for out of a hypervisor when you're talking about VDI? And then we really get into the meat and potatoes of why we believe Hyper-V is a great hypervisor for VDI. And I'll be going into a little bit of Hyper-V 101 and some basics. I would have preferred not to have had to spend time in the presentation really going over the basics of Hyper-V, but I'm finding that when I go and speak to customers about Hyper-V, there's really more misinformation than information about Hyper-V, how it works and what it does. So I feel it's necessary to keep, in this session, to really go over some of the basics and correct a lot of the misconceptions that I really see quite often cropping up in the marketplace around Hyper-V. So what is VDI anyway? Well, at its core, VDI is a desktop operating system, in most cases Windows 7, being virtualized back in your data center and then being virtually presented out to your users in say, some way, shape or form. In terms of the Hyper-V VDI solution, our go-to-market partner is Citrix, and we partner very tightly with Citrix and their Zen Desktop product. Windows Server 2008 R2 does have a session broker built into it, but that's really for smaller scale. We tend to find the tipping point is really anything between 50 to 100 desktops, depending on the maturity level of the organization. The less mature they are, the lower that number is. After that tipping point, we really start to find that the solution isn't very manageable, and we really need the value add of Citrix from both a management perspective and also the way that Zen Desktop does its architecture in terms of scalability as well. So, in terms of VDI in relation to or versus a traditional server virtualization environment, some data here from IDC, where with server virtualization, and it's obviously been in the marketplace for a long time, it's really easy to recognize and see what, where the TCO and the return on investment gains are. There's really good data in the marketplace around that, and it's pretty well proven. Just some IDC figures there on the amount who are virtualizing and some typical density rates that we see. With client virtualization, when we say it's very difficult to project ROI with unproven TCO gains, we're saying that because the solution really hasn't been in the marketplace long enough for us to get enough data to really make good calls on that. And where we see the gains really are typically for customers is a very pragmatic approach in terms of really looking at how do your users operate, what are their workload profiles, and then having a look at which solution best services them. And VDI is a very, very good solution for certain user workload scenarios. It's not necessarily something that we may recommend for an entire organization, for example, because the economies, when you look at the numbers, often the economies aren't there to do it on that kind of scale, and then the question comes up, do you really need to? We really often find that when we look at the customer's needs and we say, well, what are you expecting to get out of VDI? What do you really want to do out of it? When they describe their use cases to us, it's in a lot of cases, they'll get exactly the same benefit out of using a more traditional RDS terminal services / Zen app architecture as well, and you get much better density rates off that. So, and in fact, Tony will mention that in one of the demos that he's going to show you is around what's presented to the user from a Zen app versus potentially a Zen desktop point of view. So I'm not going to read through all of these, but these really are the core attributes of a good VDI platform and what you look for. I mean, all of these are obviously no-brainers, but what I'm going to focus on for the next little bit is going through some of the basics of Hyper-V and explaining why we believe that it's such a good hypervisor for not just VDI workloads, really for any virtualization workload, but particularly focused on VDI for this session. So I want to talk a little bit about specifically Hyper-V, Windows Server 2008, R2 SP1, and address some of the misconceptions and confusion that I see out in the marketplace when I go and talk to customers. First of all, there's two ways to obtain Hyper-V, and there's some confusion around that. I don't think we did a very good job with how we named it. They're very similar, so hence I think the confusion. The first is Windows Server 2008, so that's traditional Windows Server R2 with the Hyper-V role. So you go into Service Manager, look at roles, Hyper-V is available, you check Hyper-V, and then all of a sudden you have a Hyper-V server. Now, that is a Windows Server, traditional Windows Server in every sense. There's two ways that can be installed: full installation, which is the sort of more traditional way that it's been done previously, and also Server Core, which is doesn't have a graphical interface. It's command line only and a little bit leaner in terms of the disk and memory footprint. Our best practice, recommended best practice, is to use Server Core for Hyper-V. Because of the lower disk footprint, we find that we have to apply less patches to Server Core, and therefore there's less reboots of the host required running Server Core. We do find that, though, that's a real balancing point between running Server Core for that versus there is some added administration cost in terms of running Server Core, because the sysadmins aren't used to it. Some of their tools may not work against Server Core. So these are the things that you need to look at to say, do I want ease of management, or do I want that lower footprint and lower maintenance in terms of patching on that operating system? So it's up to the architect where that balance is going to be in your own organization as to where your support and operations teams are with their skill sets and those types of things. So they're all things to consider. 3 SKUs where we really are talking about Hyper-V, which is standard enterprise and data center. The entry point for most virtualization environments is enterprise for 2 reasons. One, clustering is introduced at the enterprise level for high availability of those virtual machines. And also standard only supports 32 gig of memory, whereas enterprise and data center take it up to 2 terabytes. And we find that most servers that are shipping today for virtualization requirements, typically have more than 32 gig in them. The other way of obtaining Hyper-V is the free downloadable version. Now, it was Windows Server 2008 R2 with the Hyper-V role. The free version is Windows Hyper-V Server. So very similar names, and hence some confusion, I think. That's a free download. That, think of it as, from a technical perspective, is roughly equivalent to enterprise server core. And that's what the free version gives you. One of the main differences is, obviously you don't have to pay a license for that version, and the other critical difference is it has the Hyper-V role enabled, but you cannot run any other services on that box. It's a Hyper-V server only. Whereas with traditional Windows Server, you can potentially install multiple roles in that box. Obviously, our best practice, if you're using it as a virtualization host, is to not install other services because we want as many resources as possible, given to the guests. But for labs and test environments and things like that, sometimes it can be convenient to install other roles. Got a question at the back? So for the free version, yes, it's equivalent to enterprise server, so it supports up to 2 terabytes of memory. So those are the different SKUs that are available. Now, the other main advantage with using Windows Server is the virtualization license rights that come underneath that. Now, I want to be very clear when I say that these are licensing rights. These are not technical restrictions. So with Standard, you're paying for the Windows SKU. That entitles you to run one operating system up to Windows Standard underneath that, which is then covered by that host licensing. Enterprise gives you up to 4, and Data Center gives you unlimited license rights underneath that. That doesn't quite apply the same when you're talking about desktop operating systems, so we do find quite a lot of customers do tend to go for the Hyper-V server as opposed to Windows Server with the Hyper-V role when you're talking about VDI implementations. In terms of deployment, in terms of management, those SKUs are the same. You deploy them the same, potentially in the same ways, and you also manage them the same. They come into the Hyper-V MMC or into Virtual Machine Manager exactly the same way, and there's no difference from that point of view. So Service Pack 1, which was recently released, added some new features from a Hyper-V perspective, which I'll take a little bit of time discussing now. The first one was our supported CPU overcommit ratio. Was 8:1 for desktop workloads with Service Pack 1. That is now increased to 12:1. I want to take a little bit of time talking about what that number is and what it really means, because again, there's some misconception in the marketplace as to what we're talking about. Firstly, we're talking about an overcommit ratio from logical CPUs as compared to virtual CPUs. I need to define what I'm talking about when I talk about a logical CPU. Our definition of that in relation to Hyper-V is we're talking about a core. So let's say you've got a dual socket quad core box. You can have 8 cores in that system. So then that's 8 logical CPUs that we're talking about. If, say, you log into Windows Server and fire up your performance monitor and you see 16 CPUs because it's hyper-threaded, then we still classify that as 8 from the overcommit ratio perspective, because a hyper-thread is not a full core. So we still say there are 8 CPUs in that box. One misconception that I've hit quite a lot out in the field is that Hyper-V doesn't work with hyper-threading. That's absolutely incorrect. Works very well with hyper-threading. Leave your hyper-threading turned on. You will get a slight performance boost out of having that turned on. But as far as the overcommit ratio is concerned, we still classify that as 8 CPUs in that example. Now, a lot of people ask me why 12? Why not 24 or 30 or, what's with the 12 number? When we say this is a supported limit, it's not a technical restriction. It's not going to, if you try and fire up a VM that's going to tip you over that 12:1 ratio, Hyper-V is not going to stop you. It's not going to say, oh, no, you're at capacity and won't allow you to start the VM. It's nothing like that. It's about, we only support what we test. And we have tested up to a 12:1 overcommit ratio. Now, we could have potentially tested a higher number, but the Hyper-V team is a very, very pragmatic, very engineering-focused development team. And so when they picked, right, what number are we going to test up to, they really said, well, in real-world VDI workload scenarios, what is a realistic number for an overcommit ratio? And from looking at a lot of other VDI implementations, how customers were running, the sort of workloads that they were using, 12:1 came out as a sensible number. Again, 12:1 is the supported limit, but you've got to apply a bit of common sense to how you look at this. let's say you've got a virtual machine that has one virtual CPU, and you put a workload on that virtual machine that pegs that virtual CPU to 100%. Are you going to get another 11 workloads on that core? No. So it's really about the workload that you're running, and you've got to apply a bit of common sense to how you look at these numbers. One of the other features that was introduced in Service Pack 1 is Remote Effects. Get a quick show of hands, because I'm interested. How many people have read about Remote Effects and has a rough idea of what it does? Okay, it's about a third. Okay, that's not bad. What we did with Remote Effects is we wanted to introduce the ability to supply 3D graphics processing capability, or the ability to consume a GPU from the guest point of view, but shared that resource from the host. So what we're talking about there is a virtualization of the GPU services. So there would be a 3D card with a number of GPUs in the server, and then Hyper-V simply shares that resource out in the same way that it does for processor, RAM and disk, in terms of making those available to virtual machines to share. The advantage with that from a client perspective is if it gives them access to 3D graphics processing capability, and there's a boatload of use cases for that, without having to have any 3D graphics processing capability on the client. So if they're running a little thin client, like a little Wise terminal or HP terminal or something like that, that has no real graphics capability in it, then they still have that ability to consume 3D graphics processing capability. And we do that without really the requirement for any specific hardware. There are a couple of requirements. The first one is that the CPU needs to have SLAT, so second level address translation. And the 3D or the GPU chipset that's installed in the server needs to be at least DirectX 9C compatible. But as long as you meet those requirements, then you can divvy out Remote Effects to your clients. It also has a requirement there needs to be a dedicated amount of RAM on the video card as separated from system memory, and how much memory is on that card is going to really determine how many users you can simultaneously support farming out Remote Effects to those users. So how much RAM it'll consume per user will depend on what resolution the clients run their monitors in and how many monitors they're running. Dynamic memory, introduced in Service Pack 1. Now I do want to spend a little bit of time talking to you about dynamic memory and how it works, and I've got a demo to show you as well. I did want to spend a bit of time on that because, again, I'm finding a lot of misconceptions in the marketplace as to how dynamic memory works and what it does. At its core, dynamic memory is actually not horrendously complicated. It's a pretty simple system that dynamically adds and removes RAM from a client based on that client's demand. Where dynamic memory is very effective is because the guest is in constant communication with the host. The guest is constantly telling the host where it is with its memory utilization, whether or not it's under memory pressure, and whether or not it needs more RAM or not. We support Windows Vista, Windows 7, 2003, 2008, 2008 R2 as clients or consumers of dynamic memory. It's very important if you're using dynamic memory to remember that needs to be at a supported level for both the guest and the host. So the host needs to be 2008 R2 SP1, and the guests need to support it as well. So in the case of Windows 7 and Windows 2008 R2 guests, they need to be at Service Pack 1 as well, because the integration components are built into the OS for those versions, so they need to be at SP1. If you're dealing with Windows Server 2008 Vista or Windows Server 2003, they need to be at the latest service packs for their respective operating systems, and then you need to upgrade the integration components on those guests once Service Pack 1 has been installed on the host. They'll then get the latest integration components, which allows them to talk to dynamic memory effectively. Now, when the product team was developing dynamic memory, they really took, again, a pragmatic approach. They went and spoke to a lot of customers around, well, in terms of virtualization and how you use virtualization, what's important to you from a memory perspective? You know, how do you want to operate? And really, the two key things really kept coming out that was really how the product team designed dynamic memory and designed it around these two things. The first one was, it's a pain for me to know how I should size my server in terms of memory. This has been a problem really since day one. It was a problem on physical servers, and really, I think up until dynamic memory, virtualization had really done very little to address that problem as well, in terms of, well, how much memory do I assign to this virtual machine? And as infrastructure guys, how often have we gone to the apps team and go, well, how much memory does your app need? I don't know. We haven't run it yet. So your only option as an infrastructure guy from there is to then over-provision to a point where you feel you're safe, and then hope you're getting the best use out of your resources at that point. So one of the ideas of dynamic memory was to take the guesswork out of server sizing, so you can have a standard of how much that you apply to servers, and then the server will appropriately size itself based on its consumption needs. Because of the way dynamic memory works, though, there are a few things that need to be aware of in terms of what services do and don't play well with it, and when it's appropriate to have it, and what sizes. The other thing that customers told us was performance. We don't want to take a performance hit from running a different style of memory technology, and we certainly don't want to get into a scenario where we have more, or effectively a memory over commits scenario, where the boxes think they have more RAM than they physically have, the host starts paging, and then performance drops off the end of a cliff for every VM that's on that box. So I want to be really, really clear with what we've done here, is that dynamic memory was designed to be able to oversubscribe, but you cannot overcommit. And a good analogy is like looking at an airline, right? When oversubscribe is when they sell more seats than they have on the plane. Overcommit is when everyone turns up to the flight and they can't service everybody who turns up. So with the way dynamic memory works, we allow to oversubscribe, but we never allow you to overcommit, because we don't want to put the host into a position where performance drops off the edge of a cliff because it has to page. One of the other concepts that we had when we designed dynamic memory was the philosophy that the guest knows best how to manage its own memory. Microsoft has put a lot of investment in Windows in terms of memory management and how clients use memory, and they know how much memory they have, and they adjust accordingly, and there's been a lot of optimizations done there. So the guest knows how best to manage its own memory. If the guest is in a position where it wants more memory and it can't get it, then it will manage that situation internally. It will start paging, but it knows how to manage its own memory, and even though it'll page, the performance will still be, reasonable, because it's really doing a lot of that logic internally. The last thing we want to have happen is the host paging stuff in and out that the guest isn't aware of, and so that doesn't happen with dynamic memory. So one thing that I wanted to illustrate here, and I'll actually show you a demo, one of the misconceptions that is out there is that dynamic memory can hot add remove, or hot add memory, but it can't hot remove. Now I want to categorically say that that's not right. Dynamic memory hot adds and hot removes. Now I suspect how this sort of misconception has come about. So when I do the dynamic memory demo, I'll show you the behavior in Hyper-V and also how it reflects back in the client, because I think that's where the misconception has come from. But this performance graph that you can see on the screen came from some VDI density testing that was performed by Microsoft and Citrix. The important line to note is the blue line going down, and the part that I want you to pay particular attention to are those little peaks. Now that blue line going down is memory utilization on the host. So as we were firing up VDI sessions and they were running through their test passes, they're consuming memory. Now those little bumps back up is dynamic memory releasing memory from the guests after they complete their test cycle. So you can see there on the performance graph that that's dynamic memory, memory being released back into the pool. So is dynamic memory just for VDI? Short answer is no. There's a lot of services that can benefit from dynamic memory. And there's some customer quotes on there and sort of the increase in density rates that they see from running dynamic memory. But the critical takeaway is that we get great increases in density without any performance hit to the system. Performance was one of the key characteristics for how we designed dynamic memory. We did not want people to suffer from a performance perspective because of the way we were managing memory. Some examples of what are good workloads: core infrastructure, SQL and web. For those who haven't seen it, there's been an excellent white paper released by the SQL team in terms of best practices and recommendations around how you run SQL with dynamic memory. Goes into, I won't say nauseating detail, but 40 plus pages of detail as to how SQL consumes memory and how it uses it, and then how that relates in terms of best practices for dynamic memory. There are some services where we don't recommend you use it. Now, again, we're realistic about how dynamic memory works and potentially where the limitations are. So one service where we do not recommend you use it is Exchange. The Exchange team have released a recommendation saying, do not use dynamic memory for Exchange in production scenarios. And the reason for that is because when Exchange runs, it knows how much memory it has, and it really effectively uses that memory to do a lot of mailbox caching, which is really critical for the performance of the Exchange system. If memory starts suddenly being taken away from the boxes, then that can have a really negative impact on Exchange performance, because memory it thought it had for caching is suddenly no longer available. Other applications that may not play well with dynamic memory: some applications may be written to assess the amount of memory that's in a box at boot time and then behave accordingly. Those applications don't play well with dynamic memory, because as I'll show you when I go through the configuration, there's a minimum start value that we give a box when it boots. And the box is only going to be allocated more memory if the box is under memory pressure and needs more. So when the box boots up, it's going to start with the min amount of memory. Some applications may not like seeing that small amount of memory and then not understanding that there is not more available to it later on. And anything that doesn't play well with hot add and hot remove. Again, depending on how the application uses memory, it's quite conceivable that some apps aren't going to play well when RAM's suddenly taken away.
Have you seen any apps break because of that to get enabled memory on clients when you do VDI?
I've not seen any specific examples of an app that doesn't play well with dynamic memory from a client perspective. The number one that I've seen from a server perspective is simply performance degradation on that app, which is usually because it's taking large pools of memory for caching. Okay, so I'm just going to flick over to my demo machine and give you a quick demonstration of dynamic memory. There we go. So what I've got running here is a 32-bit Windows 7 system. I'll just quickly show you the settings that I have for dynamic memory. Okay, so here you can see I've got, this is where you set it up here in terms of static or dynamic. I have a start value of 512 and a max value of 2 gig for this particular client. The default is maximum of 64 gig, which is the maximum that can be assigned to a Hyper-V guest. The idea there is the operating system will boot up with its minimum amount, and then we'll have RAM dynamically added to it if the box is under memory pressure and requires more, and we'll keep going up until it hits that ceiling that you set of which in this case is 2 gig. So there is still a little bit of sizing considerations that you want to make in terms of where I set my min and my max to. There's some stuff in the SQL white paper about where your min value is set to and how that relates to the amount of memory that SQL believes it has available for cache, and also the max value as well. You may not necessarily want to set everything to 64 gig. Again, how well will the app play with dynamic memory? If you've got a legacy app, for example, that memory bleeds, yeah, not a real good candidate to have dynamic memory turned on that box. So I've got a memory buffer here, and what the memory buffer does is when RAM's dynamically allocated through dynamic memory to the guest, it's not necessarily an instant process. It's pretty quick, but it's not instant. So the buffer is there for a performance perspective to say, if my service is consuming 1 gig, I'm going to be giving the box 1.2. That 0.2 is some breathing space, so that if the RAM demand goes up again, you do have a bit of a buffer there of RAM that's there for that service before then more RAM gets dynamically added. So it's a little bit of a buffer. The default is set at 20% and it's set there for good reason because of that. That's where we found the best performance level is in terms of a default. If you set that to less, the boxes will be consuming less because then they'll have a little bit less of that overhead being consumed. But if you set it to less, just be aware that that can have performance implications.
Question, Gary?
Yep, question?
How does this affect performance in like the prefetcher in Windows 7? It does impatient.
Yes, I'll get onto that. Excellent question, by the way. And underneath here, we have a memory weight setting. Now, when you have a box that has resources which are shared, sometimes you have to set priorities. So I'll go through, when I go through the demonstration, is what happens if a box wants more memory and the memory is not there to give. Well, a number of scenarios are possible depending on the configuration, and this is where the memory weighting comes into it. So that's really all that there is in terms of the settings, so you can see it's not horrendously complicated. Now, from here you can see that I'm being displayed at the moment what my memory assigned value is, which is 512, and what my demand is. So this is a x86 Windows 7 box booted with no apps running, so the memory consumption is pretty low at this point. It's only 389 meg. The 20%, that's not quite, it's a bit over 20% in terms of the 512, but the 512 was the min, so that's always going to be the least amount that's going to be assigned. So, and you can see here I've got Performance Monitor running in the, Task Manager running in the guest. That gives us our details. So we've got the memory assigned there. Now you can see that we actually have 0 free because we have, you know, a degree of memory. Whoops, we have a degree of memory in the cache. So yeah, Superfetch. Dynamic memory was designed to work extremely well with all Windows 7 memory technologies. So both Superfetch and also ASLR, which is the address layout space randomization feature, security feature in Windows 7. Just briefly, anyone not know what that is? The layout randomization? No? No? One? Okay, good. I'll quickly touch on it. In Windows XP, when system DLLs and various other things loaded into memory, they always loaded into the exact same positions in memory and direct same address spaces. Hackers love that because a lot of the time they would attack the memory register addresses directly because they knew exactly what was sitting in there. So in Windows Vista, we introduced a feature where things boot up in memory is randomized so that necessarily that takes that vector away from the hackers in terms of attacking memory registers directly. Very, very important security feature. A lot of malware authors really did, you know, it did put a bit of a dent in their operations when we introduced that feature in Windows Vista. Anyone who recommends that you turn that feature off is really dramatically lowering the security profile of your environment because that opens you up to a whole bunch of malware attacks. So dynamic memory was designed to work very well with those Windows 7 memory technologies. Okay, so let's have a look at what happens when I consume some memory. Now, I've got a choice here, guys. I can sit down up here for the next 45 minutes grinding away open Office apps, or I can cheat. Cheat? Thank you. Here's a quick tidbit for those who don't know. I've got a command prompt here on my taskbar if I want to run it elevated. The jump lists stop me from doing that. So for those who don't know, you hit Control-Shift and then that, and it runs it elevated. Little tidbit for those who didn't know. Just going to use an internal test tool that we have that just consumes memory. It's an internal tool. I can't give it to you, so don't even ask.
I believe I've asked already. So
He has asked already. Okay, so what I'm going to do is, this is just going to consume 1 gig of memory off the bat. So interesting things to look at is what happens in Task Manager and then what happens here. Whoops. What have I done wrong there? Oh. Okay, so there you can see the memory usage has jumped up from a performance monitor point of view. And if we look back in here, you can now see the dynamic memory has assigned the appropriate amount of memory for that. Now that memory is going to creep up again because that's not at the 20% buffer, and it's showing a status of memory is low. Once that buffer's been assigned, then that's going to go back to OK. This interface refreshes quite slowly, so the memory's probably already been assigned. It's just a little bit slow to refresh in the MMC. So we can see here that the consumption rate showing there is as to how that memory's been assigned. You can see now it's up to 1.7, and how that looked when that memory was assigned. Now, when I release that memory back, we'll see what happens. So memory usage has dropped straight away. You can see that in the console that it's now down at 229, and that'll creep up again as Superfetch repopulates the cache. You can see here that the memory demand has been reflected to a degree that it's changed, so it's dropped down. You can still see that the allocated amount is still at the higher number. Now, that makes sense when you think about it, because unless other services are demanding that memory, why give it back straight away? There could be another spike in demand. So we didn't want to be constantly going in and out and in and out and in and out when we didn't need to. So unless another service is asking for that memory, that memory is going to stay allocated to that box for potentially a little while before the algorithm runs again and it releases that memory back to the pool. So what I'm going to do, we're not going to sit here and watch the performance counters tick over, as much fun as that is. I'm just going to jump back to the slides for a moment, go through some slides, and I'll jump back into that a little bit later on, and by then dynamic memory will have released the memory back to the pool. I'll show you what that looks like from a Hyper-V perspective and also from a guest perspective. Now, I wanted to spend a little bit of time basically talking about the basics of Hyper-V architecture, because there are still some misconceptions out there. So Hyper-V is an extremely performant hypervisor when you're running Windows 7 workloads. So I wanted to go through the architecture and explain why the performance of Windows 7 is so good on Hyper-V. You see here a traditional Windows server installed. This is Windows Server 2008 R2, SP1. Having said that, this architecture hasn't changed since really V1 of Hyper-V. So for those familiar with Windows and x86 architecture, you've got kernel mode running at ring 0 and then user mode running up in ring 3. When we enable the Hyper-V role, hypervisor gets inserted underneath, and that runs at what we call ring -1. Now, ring -1 is made available by the virtualization extensions in the CPU. So that's the AMD or Intel VT virtualization extensions to the chipset. The original Windows Server that was installed has now become what we call the parent partition. And for all intents and purposes, that's actually running as a VM now under the hypervisor. You can see all of our driver model is up in the parent partition, and the hypervisor itself is an extremely thin piece of code. It's very, very small. It's not more than a couple of meg on disk. Within kernel mode, there you got the kernel, obviously, the virtualization service providers, and the VM bus. So when we install a guest now on that operating system, that comes in at ring 0 as well. So when I go out and speak to people, I still hear from people that they think that Hyper-V isn't a bare metal hypervisor. It absolutely is. You can see there, any guests that are running on Hyper-V, their kernels are running natively at ring 0. There's no ring compression going on. So, and again, the virtualization service client, which comes in through the integration components, and also the VM bus. So if we put another guest in, this one happens to be Linux, Linux virtualization service client, the hypercall adapter, and again, access to the VM bus. Two main reasons why Windows 7 performs as well as it does on Hyper-V. And the first one is what we call enlightenments, which is similar to paravirtualization in the Linux world, but not exactly the same thing. Windows 7 was built from the ground up to know when it's virtualized on Hyper-V. So there's a whole bunch of stuff in Windows 7 that says, okay, I know I'm virtualized on Hyper-V and I'm going to make decisions based on that knowledge. The other reason why our performance is so good is the use of the VM bus and what we call our synthetic drivers. So the synthetic driver model works through the VM bus and in the case of Linux through the hypercall adapter. Now, in terms of access to those synthetic drivers, certain Linux distros are supported. So that's Red Hat, CentOS and SUSE Linux. At supported versions also support the synthetic driver model. So you get very, very good performance from those Linux distros as well. So it's not just Windows. The advantage of the synthetic driver is basically reduction in context switching. When we use an emulated or a legacy adapter, what happens is the hardware call goes down through the guest operating system, has to be intercepted by the hypervisor because in a lot of ways, virtualization is effectively spoofing a hardware layer, right? You're making the OS think it's running on native hardware. So the call comes down, is intercepted to the hypervisor, then has to be routed back up through into the parent partition, and then the call translated and put down through there. There's a lot of context switching between user mode and kernel mode when that process has to occur. When we're using a synthetic driver, the call is made directly through the VM bus, and there's I would say orders of magnitude less context switching that goes on. So not only are the synthetic drivers dramatically faster, but they also then carry less overhead in terms of the CPU load on the hosts. So there's a recommendation in terms of best practice for Hyper-V is absolutely use synthetic drivers everywhere you can. And the only reason you should ever really use a legacy adapter is some sort of compatibility reason, and to be honest, I'm yet to find a compatibility reason why you need to use a legacy adapter. That's my other one, right? But in terms of application or network compatibility, I've never found a reason to use a legacy adapter. And then the other reason is PXE support. As you can see from the architecture, it utilizes the VM bus in order to operate. So when you're in PXE, there's no kernel mode because there's no operating system yet, so it's a bit difficult for the VM bus to work in that scenario. So we have to use those legacy adapters to get PXE boot support. But again, PXE boot, if you're doing OS deployments, then really you should be looking at using virtual machine templates as opposed to PXE sort of bare metal build techniques, with the one exception notably of the Zen desktop architecture, which Tony's going to go through. And with that, I'm going to pass over to Tony. Actually, just before I do that, I will jump back in and show you the conclusion of that, where we are with that dynamic memory. So, okay, you can see here that memory has now been released back to the pool, so the allocated memory is now back to 512. So dynamic memory has done its deterministic algorithm, seen the memory is no longer needed, and released it back to the pool. Where the misconceptions come from, I think, is when you then look at how that looks within the guest. So the guest is still reporting from a task manager perspective that it has 1.7 gig available. Now, at the moment within the latest version of Windows, you can't actually hot remove RAM from a guest perspective. So what we need to do is we have a balloon driver in place that then actually consumes or tells the guest that that memory is now being consumed and is unavailable to the guest. So the memory is not there. It has physically been released back to the pool, so the physical memory will be used by other services that require it. The guest thinks that it still has that maximum amount of memory because we can't, from a guest perspective, it can't really be notified that that's been, dynamically removed. But dynamic memory was very carefully designed in terms of how the balloon driver works, in terms of, again, the guest best knows how to manage its own memory. It does not think that that memory is available to it. So it will behave and potentially page according to the fact that it has 512 allocated to it, which is what the box really has. I just wanted to quickly go through some scenarios in terms of what happens then if I need more memory and the memory isn't there. So let's say I've got a maximum, again, of 2 gig allocated to that guest. There's a lot of VMs on that host. It's running a minimum of 512. The service fires up, and it's asked for another 1 gig of memory. Let's say that 1 gig isn't available on the host to give, that there's no more memory left on that box. A number of things can happen. Firstly, we'd like to think you'd be potentially running that machine in a high availability cluster, And if you are and you're using the Pro Tips integration with Operations Manager, then the system will be notified that that box is under memory pressure, that there isn't the memory on that host to give it, so it can live migrate it off to another box that does have the memory to allocate. That's one scenario. Another scenario is, let's say you're not in a clustered environment and the memory you have is the memory you have. It'll then actually look at the weighting, which is the slide bar I showed you before, of the guests relative to each other. So if there's a box that is consuming memory that has a lower priority rating than the box that's asking for memory, that memory will be taken from the lower priority box to be given to the higher priority box. If the boxes are if it can't do that because the boxes are at equal priority, then simply the guest will not get the memory that it needs, which means that the guest will start paging, potentially, because it doesn't have enough memory. But again, it will be doing that as fairly efficiently because the guest best knows how to manage its own memory. And best of all, you won't get into a situation where the performance of every VM on that host tanks because the host is paging. So those are the scenarios if there isn't enough memory to go around. So I'll now, after that, flick back to the deck, or did you want to run the demo first?
No, we'll go through the deck.
Yep.
So we're only going to spend a few minutes on this. Like we talked about earlier, tomorrow's session is really about the how, the scalability results we achieved working together with HP. What did we get? How do we architect it? All the answers in terms of IOPS, in terms of dynamic memory, in terms of dynamic VHDs. All of that information we're going to give you tomorrow. So do your best to try not to have too much of a good time tonight because it is brand new information. It's a brand new reference architecture. So I'll really go into that hard tomorrow, and you want to really attend as much of that as you can. So I'll only spend a few minutes going through the architecture, but if you're a current Citrix customer, do me a favor, raise your hand. Oh, brilliant. All right, we have gurus in the house. Excellent. So this is going to be easy. Again, it's only 5 minutes just to give some people an introduction. With version 5 of Zen Desktop, and actually more so now 5.5, we actually came out with 2 different architectures. Traditionally for Zen Desktop and VDI, it's been using provisioning server. So in this architecture, you can see we have a series of communications. When a user logs in, by default, they're going to go through a web interface portal, make the backend communications back to the hypervisor, in this case, Hyper-V. In order to make a connection to that hypervisor, we need SCVMM. He is the most important man in the middle because he manages the power state of everything that happens on Hyper-V. We cannot do our job in the sense of creating desktops, powering up and down without the use case of SCVMM. Very, very important. Now those changes in the sense of VMM SP1 as well as Hyper-V and Windows Server SP1 made a big difference for us. As Garrett talked about, dynamic memory really changed the scale of how VDI is calculated and how many VMs you can put on a particular blade or server. So those features are really, really important as you're looking at designing a new VDI architecture. But when the VM boots up, again, you'll see in this particular architecture, he's going to go through, make a connection, talk to Hyper-V, talk to VMM, and then effectively get a particular desktop that's delivered to him. Now, in either scenario, depending on what the architecture is, you could get Windows 7, you could even get Zen App hosted on Hyper-V. Either one, in certain use cases, could be potentially considered VDI. It just really depends on how you look at it. Both are virtualized operating systems, but both have different TCO models in the sense of what they cost and in terms of how they scale. So what we're going to do is kind of go past this one and really go to show you a demo of everything. We are on 4, I believe. I'll give this a second to refresh here on the screen. So you're looking at my desktop, and in the interest of time, what I've went ahead and done is logged into a series of desktops. Now you'll see here the first one that I've logged into, again, it looks like Windows 7. To the end user, they really don't care what some things look like. They really care primarily about the apps, but then you're going to have a couple people, maybe they're all picky in the finance area. They want what they're physically used to. And for that is that skin effect, that look and feel of Windows 7. With Zen App 6.5 that we recently released, and we actually had a session earlier on that, we have the ability to go ahead and apply what was normally done via a bunch of group policies, now in a MSI-based package, the ability to go ahead and populate the look and feel of 2008 R2 with Windows 7. So this desktop here you see that I've logged into, this is actually a 2008 R2 host. But because some users may want that look and feel, it's very easy to use this new management pack feature and say, you know what, I'm still going to give you all your apps, still hosted, but because you're picky and you want Windows 7 look, here it is. But to compare it, if you look at this desktop here and this desktop, they're pretty much identical. You can't really tell a difference between one that is RDS/Zen App or the one that's just pure Windows 7. They almost look the same. So to know that information is kind of helpful because you're going to have a subset of people when you use your user segmentation, they're going to define, hey, you know what, I need this model because it's more cost effective for my business unit. That may be the Zen app role. And then for the other business unit, great, Windows 7, delivering it on Zen desktop. But either way, what's kind of cool about it is when the user comes in, if I go back to my particular portal here, the user is going to get either one of those choices. They're going to be able to get the desktop that is provisioned to them. And either one of those desktops could be either the full Windows 7, it could be either a Zen app hosted, and for them, again, they may not necessarily care. It's just giving them what that user segmentation is about. In either one of those circumstances, when they've got their desktop, again, they may just care about getting that subset of applications. Now here, I've got a couple of apps here, Office that's hosted and delivered. What's pretty powerful about this is if I go back to my Windows desktop here, and we kind of drag this one over, you'll see I've got the receiver bar listening. Any one of those applications that are virtualized with app B and managed via System Center Configuration Manager can be automatically pushed directly into either architecture. We support the use case of being able to take that subset application and push it here. Here's my Office streamed here. Now that application, again, follows that user in that virtual desktop. Now maybe that makes sense for that particular business unit, but in this business unit here, it may make sense just to give them some apps that are locally executed and live inside that Zen App RDS environment. So that is a flexible architecture, and that's really important because you have that flexibility and choice, whether it's Zen App or whether it's pure Windows 7. And we'll go back to 2, and that pretty much concludes my 5 minutes of fame for this session.
Don't worry, if you're dead keen to see more of Tony's beautiful face, come to the session tomorrow morning because that's really his session than mine. So he'll speak at length about Zen Desktop and the architecture and how we did that testing. We'll also have people from HP who'll go through the hardware architecture as well. So there's some a list of resources there. Don't go frantically writing or taking photos or whatever. I mean, the decks are available from the, all the content's going to be published up on the TechEd site, so the decks are available for everybody. And we have over about 7 or 8 minutes left, so if anyone else has any questions, feel free to fire it up. But otherwise, thank you very much for your time, and come to the session at 8:15 tomorrow if you're conscious.
Thank you.